Today I'm talking about the line integral. The line integral is the sum of vectors along the path L. One example is work done in moving charge Q from one point A to another point B along path L. We have point A and point B. We consider moving plus Q coulomb from point A to point B like this. This is a continuous path L. I will take some point on path L. I will take 5 points. This is L1, L2, L3, L4, and L5. And electric field on L1 is this. This is E1 vector. And on point L2, the electric field in the E2 vector. For point L3, the electric field is E3 vector. And this is E4 vector. And on point 5, the E5 vector. So we take the sum of the L component of E vector. This is L1 component of E1 vector plus L2 component of E2 vector plus L3 component of E3 vector and L4 component E4 vector plus L5 component of E5 vector. And this is the work done is against of electric field, or minus Q multiply this. It is work done in discrete point. And this is minus Q summation from n to 1 to 5 E n vector dot L n vector. However, the path L is continuous path and there are many points on path L. So this summation transform integration. So this can be line integral. So minus Q point A to B E n L n. The more exactly we can rewrite this is minus Q integral from A to B along path L E n dot L n vector. So the initial point and final point and the path L should be given. So these 3.3 are given. We can calculate the line integral and work done. So I will take an example. So electric field is given y ax vector, x ay vector, and z 2az vector. Find the work done 2 coulomb from B to A. This is B and 1, 0, 1 and A along this path. This is on these 2 points on the circle. This circle is x, y, and z equal 1. This is a 1, 1, minus 1, minus 1. In 3-dimensional, we can draw this path is, this is y, this is x, this is z, and z equal 1, and this line, this is the path. The path can be the counterclockwise or clockwise. So generally we assume the path is counterclockwise. So this is this is L vector. L vector is this direction is pi direction, and R rho is 1, and 1 multiply d phi a pi vector. This is the L vector, and E vector is y ax vector, x ay vector, z plus 2az vector. So the work done from point B is 1, 0. 1, 0 is this point. 1, 0, 1, and 0, 8, 0,0,6, 0,82, 0,6, and so at this point. So the path is this path. Along this path, we find the work done. So this is work done is against the electric field, and Q is 2 Coulomb. Integration the E vector and dl vector, dl as d phi a phi vector. This is for this is integration for pi. So electric field vector in rectangular coordinates should be transformed electric field in cylindrical coordinates. So E vector is expressed by a rectangular coordinate system y-ax vector plus x-ay vector plus 2az vector. So we input x equal rho cosine pi. The rho is 1, so this is cosine pi, and y equal rho sine pi. Since rho equal 1, so this is sine pi. So electric field vector can be expressed in cylindrical coordinate like this. Y is sine pi ax. So we calculated this line integral. Minus 2 is vector y ax vector plus x ay vector plus 2az vector. That a pi vector d pi. So pi, this is the range of pi. 1, 0 is pi equals 0. And this is rho equal 1 and z equal 1. The pi is, this is a pi. This is pi's arctangents. Y over x. So this is arctangent. Y is 0.6, x equals 0.8, so 0.8, 0.6. So arctangents 0.6 over 0.8 is 36.87 degree, or 0.644 radian. So we use the radian because this is the upper limit. So this is from 0 to 0.644. So this is sine. Okay, so we firstly we calculate this. This is y. This is integrand is y ax dot a pi plus x a y dot a pi plus 2 az dot a pi. Az vector and a pi vector is perpendicular, so this is 0, and this is x axis, y, so this is ax, ay, and this is a rho, this is a pi. So the angle between ax vector and ay vector is 90 degree. Also, the angle between a rho vector and a pi vector is also 90 degree. This is pi. This is pi over 2 minus pi. This is pi. So ax dot a pi is, this is cosine pi. This is y cosine pi plus x. Ay dot a pi is a pi. This is the a pi, and ax is pi over 2 plus pi. This is y cosine pi over 2 plus pi, and ax dot a pi is cosine pi. So this is minus y sine pi plus x cosine pi, right? Minus y sine pi and x cosine pi. So this is y. So we input y is sine pi and x is cosine pi, and this is minus sine pi plus sine square pi plus cosine square pi. So the work done is minus 2 integral from 0 to 0.644. This is minus sine square pi sine square pi plus cosine square pi d phi. This is minus 2 integral from 0 to 0.644, and this is minus 2 1 minus cosine 2 pi plus 1 plus cosine 2 pi over 2 d phi. So this is a minus 2 integral from 0 to 0.644 cosine 2 pi d phi. So this is minus sine 2 pi from 0 to 0.644. This is minus sine 2 multiplied 0.644. This is the answer for this question. The work in this question, the work is has minus sign. It means we get work. That work done is not work done. We get work, right? So its meaning is we get work. So next is we try to find the work for infinite line charge along z-axis. So we try to find potential from low equal b to low equal a due to line charge. So we have already known electric field infinite line charge along the z-axis is like this, and the work done is the against of electric field and the moving plus q coulomb from the path from the initial point A to final point B. This is we can calculate. This is minus q integral E is rho L over 2 pi epsilon 0 rho a rho vector. The dl vector for cylindrical coordinate is the rho a rho vector plus rho d pi a pi vector plus dz a z vector. The a rho vector is perpendicular to a pi and a z vector, so this is 0. Only a rho component is survive. This is minus q integral rho L over 2 pi epsilon 0 rho d rho. This integration is for rho, so the lower and upper limit is the range of rho. The range of rho is from B to A. So from B to A. So this the in point of rho L over 2 pi epsilon 0 is constant. So this constant can go out the integration. So minus 2 pi epsilon 0 rho L Q and integral from B to A 1 over rho d rho. This is B to A. So this calculation becomes minus rho L Q over 2 pi epsilon 0 and rho from B to A, rho equal B to A in minus rho L Q 2 pi epsilon 0 ln A minus ln B. This is minus rho L Q 2 pi epsilon 0 ln A over B. In order to make this minus sign be plus sign, so this is rho L Q over 2 pi epsilon 0 ln B over A. So yeah, this is some incorrect. This is from yeah, this is correct. B over A. This is a typo. This is typo. This is B and A, and this is B and A. B and A is correct. This is typo. B and A. So we take an example. So evaluate. Find the work done in moving 4 coulomb charge from point B to point A along the straight line. So we electric field is given, and the work done is against the electric field Q integration E vector dot dl vector. So the point is how to find the dl vector. So we try to the path L, find the path L, S and Y, Z, and 1, 0, 0. This is 1, 0, 0, x, y, and this is z equals 0. This is xy plane. 2 and this is the L vector. This is the L vector, and the L vector is the x vector and the y vector. So the L vector is the x ax vector plus dy ay vector. So this is minus 4 integration 5 x ax vector plus 5 y ay vector dot dx ax vector plus dy ay vector. So this work done is minus 4 integration. This is minus 4 integration 5x ax vector, 5x x not ax dx vector plus 5y dy vector, and we can separate this integration because x and y are independent. But minus 4 integration 5x dx. X is from 1 to 0, so this the lower limit is 1, upper limit is 0, plus integration 5 y dy. The lower limit is 0 to 2. This is 0 to 2. So this is minus 4, minus 20, and integration from 1 to 0 x dx plus integration from 0 to 2 y dy minus 20, and this is 1 over 2 x squared from 1 to 0 plus 1 over 2 y squared 0 to 2. So this is minus 10. It becomes minus 10. This is 0 squared minus 1 squared plus 2 squared minus 0 squared. This is minus 10, and this is minus 1 plus 4. It's a minus 30. The unit is joule. Also, this also the work we get work, the not work done. So next example is the electric field is given, and we try to move 3 coulomb and below. The first question is so y and x. Z. So this is 1, 3, 5, 5, 1, 3, 5, and 2, 3, 5, 2, 3, 5, first 2, 3, 5, and 2, 0, 5, 2, 0, 5. We move 2, 0, 5, and 2, 0, 3, 2, 0, 3, like this. The work done is minus q integration e vector dot dy. Q integration e vector dot dl. We have four paths. This is first path, second path, and third path. We have three paths. So this is minus q integration. The work done by path 1 e dl, and work done by path 2, work done by path 2, and work done by path 3. And this q and minus q. The q is 3, so this is minus 3 integration. Electric field vector is y-ax vector, y-ax vector, and the L vector is this is a rectangular coordinate, so this is the x-ax vector plus dy ay vector plus dz az vector plus integral y ax that dx. So this is the same. So same. This is y dx, y dx, y dx, and this is y dx, y dx, because the EDL vector is in rectangular coordinate is EDL vector is y ax vector dot dx ax vector plus dy ay vector plus dz az vector. This is y dx, so this is y dx. First is 1, 3, 5 to 2, 3, 5. Second path is 2, 3, 5 from 2, 3, 5 to 2, 0, 5. Third path is 2, 0, 5 to 2, 0, 3. As the first path, we minus 3, and x is from 2 to 1, and x is 1 to 2, and y dx, y equals 3, z equals 5, y equals 3, z equals 5. And second is 3, and the second path is from 2 to 2. This is a 0, right? That's 2 and 2 is a 0, so it's minus 3 integration. The x is from 2 to 2, y dx, this is 0. So only this integration survive. So work done is minus 3 integration from 1 to 2 y dx when y equal 3, and this is minus 3 integration from 1 to 2 3 dx minus 9 x from x equal from 1 to 2, and this is minus 9 joule. So we got the work 9 joule. The second question is, this is the initial point and final point is the same, but the path is different. So this is work done is minus 3 integration 1, 3, 5 to 1, 3, 3 y dx minus 3 1, 3, 3 and 1, 0, 3 y dx minus 3 1, 0, 3 and 2, 0, 3 and y dx. The x is from 1 to 1, so this is 0, and x is also 1 to 1, 0. So this is the third term survive, so minus 3 and x equal from 1 to 2 y dx y equals 0. Since y equals 0, so this is 0. This is we didn't work at this on this path. So at this question, although initial point and final point are same, the result, the work done, may be different according to the path. So this is the question, the answer of question 3. Today we're talking about line integral. One example of line integral is work done. We have already discussed in previous section. So we take some example to find the work done by line integral. Thanks for listening to this video, and see you next time. Bye bye.